Today we are going to have a presentation on nanomaterials, the materials of the future. Uh, the main contents of this presentation will be the introduction to nanomaterials, the constituents of nanomaterials, the different types of nanomaterials, and finally we get into the applications and the potential of nanomaterials in today's world. Let us first start with the introductory part of nanomaterials. Nanomaterials belongs to the concept of miniaturization of materials. They involve a very different production approaches which are not very similar to the traditional methods what we use. So there are two ways of going for manufacturing of nanomaterials. One approach is a top-down approach, another is called as a bottom-up approach. Although many nanomaterials are currently in the stage of manufacturing in a laboratory, a few of them are being commercially used in today's world. So, examples of nanomaterials is aimed at understanding its properties, its behavior, and it is very well used in medical fields nowadays. So, coming to the types of nanomaterials, so it is basically grouped into four categories. One is called as a carbon based materials, another is called as a metal based materials, the third is called as a dendrimers, and fourth are called as composites. So the nanomaterial based composites are hot in today's world, and they have been seen a tremendous growth in the past 10 years. So we'll just look at what is the concept of a nanomaterial. Nanomaterial is a broad and interdisciplinary area of research and development activity that has been growing explosively worldwide in the past few years. So it has a potential of making a revolution in changing the entire concept of a material. So it is already having a significant commercial impact, which will be very rapidly increased in the coming days. So this is to show the constituents of a nanomaterial and how the constituents are arranged in layer by layer formats. You could see the different types of nanomaterials being shown on the bottom. So this block indicates how the development has gone from materials to smart materials and nanomaterials. So materials do have a capacity of bearing the loads, and it doesn't have the capability of responding to the environment. But the smart materials do have the intelligence of responding to the environment and act in conjunction with the requirement. The example of smart materials being the shape memory alloys, um, the magnetorheological materials, piezoelectric materials, and other materials which do change with the temperature, with the strain, and other parameters, and it is effectively used in many applications. The common factor of materials and smart materials will go to nanomaterials, where the nanomaterials is reduced onto the nanoscale, and these nanoscale materials will have advantages, unique advantages than smart materials. So this particular slide explains the evolution of the nanotechnology, how it has taken place. First, the idea of being reducing to the nanoscale by increasing the chemical reactivity and the quantum effects was realized. Then the nanotubes and semiconductor nanostructures were developed, And silicon based nanomaterials, molecular imprinted polymers, and silicon platforms are envisioned for collection, concentration, and detection of chemical weapons.